Buenos días, mi nombre es Máximo Serengui, representante de Chile de la ESO. Gracias a todos los presentes, profesores, autoridad, amigos y amigas. Hoy vamos a mostrar otra forma de globalización, cuando todo se junta en un lugar. En un programa tenemos vamos a presentar diferentes aspectos. Que tenemos también una palabra de tradicional del deseo 1245. De tradicional sentido de la vida de Santelería, un evento muy importante al mediodía, a una que no puede estar con nosotros este evento. De esta manera, la palabra al tradicional y dar un saludo a todos. We are going to use the English Spanish in reality ESO language for language of a stone is English, but feel free to use any language. Finnish. And in Japanese too. Swedish. Okay.
Thank you, Massimo. It is certainly a pleasure to see so many of you here, so many dignitaries in the government, ESO members, Chilean economy community, etc., etc. It's certainly a pleasure for me this event and to tell you a little bit about it. You will get much more in a moment. It is really nice to see that our observatory in Paranal, in particular, now will have a fast data link to the rest of the universe. Very isolated there it is. And I find it very interesting that this was done in a collaboration involving EUNA here in Chile, and the European Union, supports building of infrastructure. And what is also quite interesting is that it is not just Paranal, which of course is ESO's flagship observatory, but this team, hello, Roger Filippi from ESO, had the foresight to build a partnership that would also connect Cerro Amazonas to the rest of the world through a fast data link. This is of course because of the Volcan telescope. The director there, Volcan, I suppose, watching us, called Chini. But beside Amazonas is of course also the mountain which will have hopefully very soon, take a little while to build, the world's largest and best optical telescope, the telescope. That project is making very good progress, and the ESO Council is very likely to take a decision on the construction, which cost a lot of money, in the course of 2011, hopefully before the Northern Summit, so in June. Okay. For now, basically, the data streams can flow everywhere, and I'm very pleased to see that this indeed attracts attention. This is also wonderful for our observatories and will enable faster data transfer and therefore even more discoveries with our telescopes. Massimo, maybe I should add, you did say, I think, that I hope Mr. Massimo will come to his building at 1 o'clock, so we'll have to unfortunately disappear, but higher authority calls and we simply say, yes sir. Here it is, thank you.
Thank you. And now we go into the program with Fernando, that is the director of the EVALSO project, and he will explain what has been done in the course of this month and year, and why today we have to be happy to be here and celebrate.
Thank you, Martin. First of all, world-class facilities are world-class infrastructure. Here in Chile, there is a number of world-class astronomical facilities, but after also the connectivity of these facilities with the rest of the world was hampered by a number of reasons. This was the reason we jointly decided a group of European institutions towards, together with ESO and with the very strong support of the European Commission, to start this project EVALSO, that was the space for enabling virtual access to Latin America and Southern Australia. And this was aiming at creating, first of all, the physical infrastructure that connects that remote area of the world, that is the desert of Atacama, in which the two observatories that we are connecting are placed. And then creating facilities that could be used for the family of the observatories one, but also can be used in other fields in which remote interaction is important. The problem of world-class facilities is that they imply a lot of traveling that has a cost in terms of economics, that the cost in terms of social impact. Away from home for very convenient. And this is the problem for the universities, for the academy, for the research institutions, for themselves. The EVALSO project is not something standing in the void. It works, and it will work even better in the next. It cannot, just because other infrastructures exist. Some of these infrastructures have been funded by the Chilean government, or indirectly by the Chilean government, the National Research Network of EUNA, that connects so many universities and research centers in Chile. And those have been funded by the European governments and by the Commission, like Red Clara, that is contributed very strongly by the whole Latin American community and the European Commission, the GIANT, that is the European Network in the Flow, and the National Research Network. So, what we are trying to open, we are opening now, and we have been trying to build in these 2 years of life of EVALSO, has been the red part of this scheme. The red part of the scheme, it was the most difficult because nothing was existing before. We had to face the problem of creating a completely new infrastructure in the desert, and to convince what had become our friends of commercial providers in Chile to provide the connectivity between Atacama and Santiago, in order to connect finally there in Santiago with the rail infrastructure and the infrastructure that is run by Clara, that is the continental backbone in Latin America. Then we have to go to the rest of the world, and here we come to problems because we have problems of crossing the Atlantic, and again we are building on the strong investment that we made by the European with the GIANT network and the interconnected. So, EVALSO is a number of activities. The first of all, and the most important, because all the others depend on it, is the creation of the infrastructure. That is also the proof that fast access is possible even in remote locations like the Atacama Desert, and even more important, proves the possibility and the validity of remote interaction between remote technical and educational that is really having the responsibility of running the telescopes and the instruments in different locations. These have a strong impact on the possibility of making new kind of work in this place, because the robustness also implies that the reaction time can be relatively long if something really unexpected happens. And the possibility of having the virtual presence, the virtual support of something that is staying at home in Europe or in the world, and can give the help of its knowledge to help the people on board is extremely important. EVALSO has a number of side effects. The creation of EVALSO, as I said, is building on other infrastructure and is also strengthening this other infrastructure. The result of EVALSO is that the Chilean National Research Network EUNA is becoming stronger and more up to the frontier of the networking, and integrates very well with the Clara continental backbone, again helping Clara to become stronger and more manageable and more sustainable. And it is the element of further development that can be used directly in the observatory or can be used elsewhere, and so it is a sort of fertilizer and a seed that can be found to grow. What happens next to EVALSO? EVALSO, we are opening now the infrastructure itself. That means that we are going to multiply by about 100 times the capacity of the connectivity with the observatories and the rest of the world. It is not the final solution. It's not the ultimate solution. It will become the ultimate solution where we will have removed the last bottleneck in the communication of scientific and research around the world. Now this bottleneck exists, especially between Latin America and Europe, and we are supporting it. Now the capacity of EVALSO is in the order of 10. The intercontinental, I will not use the units, just to give you the order of magnitude. It is 10. The intercontinental connectivity today for the whole of Latin America is 1. This is a very strong limitation that we are seeing. But in the meantime, I think we can be happy of the first step we have done, and I think we have to congratulate and thank the people that have worked very hard to make these 2 years EVALSO a reality. First of all, Giorgio Filippi and Sandra Zacche of Reuna and of ESO and Reuna, who have been really responsible, the people who have worked to make the first part of the infrastructure a reality. And what is even more important is this work that not always happens within the budget, but I think is important to do. So we leave the floor to Giorgio and to Sandra in order to illustrate the development of the infrastructure itself.
Many thanks to Fernando for this nice introduction. Of course, without Fernando, the project would not be there. So whether we could do it is only because he had the original idea. He called me one day and say, "What about?" And from that, we built up on some thoughts, getting more people on board, and come to the point where we are today. That is basically, I think, world-class communication infrastructure for world-class observatories. So the two things go very well together. The place where the fact happened is in origin, the north part of Chile. It is Santiago Antofagasta. That is a big jump, because Santiago is the data port where things in terms of data get out of the country. And Antofagasta is the reference point for the observatory. The two observatories that we wanted to serve with fiber installation are the Observatory in Cerro Paranal, and the Observatory of Cerro Amazonas. Now, just to, not everybody has the pleasure, like we have very often, to travel there. We can see a short view of the north region of Chile. You see that it's a pretty difficult terrain, and actually there is the place where the people have dig the hole where the fiber had to be installed. On the background, you can see a mountain that was Cerro Amazonas. We see it later. This is VLT, Cerro Paranal, is the base camp. This is one of the places where the fiber is already installed, so this is the point. The second area is the Cerro Amazonas. Near the Cerro Amazonas, there is the Bohumol Observatory. That is the second of our customer in terms of infrastructure of the fiber. As you can see, it's a pretty difficult environment. The overall system is based on a certain point that we want to connect the two observatories, then the area of Antofagasta, where there is a presence of Reuna in terms of collecting point for university located in the town. Santiago, the big jump between Antofagasta and Santiago is what we call the backbone. And within the metropolitan area of Santiago, we have ESO here, Reuna, Providencia, and the Clara installation, that is the data port for the international access. As you can see, the system is based on some dark fibers, or fibers that are dedicated to the project.
and where basically the capacity that you can put on it is without limit. It's depending only on the type of equipment you have, but there is no limit because you have the wood fiber. Instead, in the backbone, of course, for reason of investment, we have a single channel that is a one wavelength. Currently, is a 10 gigabit wavelength, and still, it's a pretty big pipe. If we get into detail, we have created a new infrastructure in the terms of new fiber that have been laid in the ground. This is a special cable directly for, somebody wants to have a look later, there will be an example. This cable goes actually from the Paraná area down to the crossroads to the New Panamericana. It's about 80 kilometers. That's the part where there's nothing. At the Panamericana, we can jump on the existing infrastructure, namely a fiber cable owned by Telefonica, where we could get one fiber that brings us to Antofagasta. The second branch of this infrastructure goes to Cerro Naciones, and now we will see a little bit how this has happened. We have installed along the road using the Franca Fiscal, so-called, and the construction is made with special machines that are preparing a trench, a ditch, where the cable is laid down. This cable is for direct installation. The cable, once is laid down, is covered with a little bit of ground of earth, and then with a special plastic ribbon for safety for future. They are not covering that with the hand all the time, but the first layer is done by hand because it's a little bit more delicate and comes the machine. The cable comes in 4-kilometer reels that have to be connected together in order to create a continuity. This is done by fusing one by one the 12 cores that are inside the cable. As you will see, the cores are small, and what you see is the plastic that is around it, because the real fiber is minimal, it's a couple of hairs. So that is the point where two pieces are becoming one, and so on until the 80 kilometer have a single unique medium solid transmission. The connection is hosted in a box, it's called a splice box, and this is placed in a chamber, concrete chamber, that will protect it. Later on, everything is covered with earth, and if you drive now from Antofagasta to Paraná, I challenge you to find where the fiber is. And so you have the problem to find it, to recognize all the things. Because one of the points we wanted to have is not to impact the environment, not to have a visual impact as an aerial line. That was a byproduct that we managed to have. We are now at the big jump, that is between Antofagasta and Santiago. Here we already created a sort of port for the future. In addition to what is the services observatory, there is also the possibility for REUNA to increase their presence, their capability of receiving data in two steps in between, Copiapó and La Serena. So basically nearly the whole north of Chile, we have a strong, better service of what is the academic infrastructure. Coming to the Santiago metropolitan region, we have the two fibers coming from the Telefonica. Telefonica is the provider that has given us the backbone and the line from the joint point from the new fiber to Antofagasta and the connectivity in Santiago. From Telefonica, we reach REUNA and we reach ESO with dark fiber for creating this last link. The plan is to add new lines in order to have in future a ring that will connect also Clara and will give availability and resilience to the whole network. At this point, I pass the word to Sandra that will talk about the equipment. I apologize, I plan to say something in Spanish, porque pienso que mi castellano puede ser entendido, pero por alguna razón rara me quedé en inglés. Si alguien tiene alguna pregunta específica, después estamos alrededor. Gracias.
Bueno, para completar lo que Giorgio nos comentó respecto a los enlaces y a las fibras, naturalmente necesitábamos equipos. Y estos equipos tenían que cumplir ciertos requerimientos, por supuesto, y entre ellos está el poder permitir conectar los sitios a través de la fibra que comentó Jorge. En particular, la fibra que se puede visualizar entre Paraná y Antofagasta era uno de los desafíos, dado que es un tramo de alrededor de 125-130 kilómetros, en el cual no se puede poner equipo en el medio. Por tanto, era una de las complejidades que debían resolver los equipos que teníamos que adquirir. La siguiente era la compatibilidad con la solución de larga distancia de lambda entre Antofagasta y Santiago, en particular con los equipos de la empresa que se adjudicó. También era un reto, porque no es algo que esté muy probado, muy documentado en el mercado. Y finalmente, la solución de los equipos tenía que permitirnos establecer enlaces separados, capacidades separadas a través de toda esta infraestructura de las instituciones que van a compartir lo que acabamos de comentar. Por ejemplo, el enlace en rojo entre Paraná, el Observatorio Paraná y las oficinas de ESO acá, los de Reuna, los de Cerro Almazones y el de Nodo de Clara, que también va a utilizar esta infraestructura. Para ello hicimos una licitación en la cual participaron 4 grandes fabricantes y se adjudicó el equipamiento de marca Siena, modelo 4200 que está aquí, por varias razones, entre ellas un equipo compacto, un equipo escalable. Las interfaces nos permiten una variedad de capacidades y de protocolos que hacen que la solución sea muy robusta y podamos también pensar en algunas cosas nuevas a futuro. Y en particular, aquí hay 12 fotos, digamos, de los equipos que ya están instalados y podemos ver 2 modelos, uno que es más pequeño, que es para los nodos terminales, para los nodos de acceso que le llamamos nosotros, que están ubicados en el Observatorio en Paraná, en el nodo de Reuna en Santiago, aquí en ESO Vitacura y en el nodo de Clara. Solo una aclaración, el equipo de Clara está por instalarse, el resto ya está todo instalado. Y el equipo que ustedes ven a la derecha es el equipamiento troncal, también de la misma tecnología, pero es un equipamiento que tiene mucha más capacidad de crecimiento que los que están en los nodos terminales, aunque estos también tienen capacidad de crecimiento, si lo necesitamos. Indicar las empresas que nos acompañaron, primero agradecer a todas, la verdad que nos apoyaron durante el proceso de desarrollo de este proyecto. Tuvimos 12 grandes licitaciones, pero en particular las que están acá son las que, digamos, por distintas razones, las que nos acompañaron durante la ejecución del proyecto. Axis, que tuvo la responsabilidad de la instalación de la fibra en los videos que nos mostró Giorgio, que son muy clarificadores. Telefónica, que es quien nos provee el lambda entre Antofagasta y Santiago, más ciertos tramos de fibra, y Adexus, representando a Siena, que nos provee los equipos, la instalación y todo lo que va a ser el mantenimiento de esta infraestructura en el mediano y largo plazo, porque nos va a durar, esperamos, mucho tiempo. Y comentarles, y aquí está la razón por la cual tenemos que estar muy felices, es porque al principio del proyecto teníamos un objetivo, una meta, que es la que está plasmada acá, que Fernando también nos comentó, y hoy día podemos decir con mucho orgullo que llegamos a la meta, que lo cumplimos, y la verdad que lo cumplimos, creamos nosotros, con creces, más allá de lo que nos habíamos planteado originalmente como infraestructura en este proyecto. Y lo que viene ahora, voy a volver la palabra a Giorgio para presentar de alguna manera que ustedes puedan comprender qué es lo que nos permite esta gran infraestructura, esta gran capacidad que está implementada hoy día. Giorgio nos va a hacer una comparación entre 2 sistemas de videoconferencia y también mostrar Cerro Almazones para que ustedes vean también pruebas concretas de que cuando decimos que está todo instalado es así. Giorgio.
Muchísimas gracias, Sandra, por tu introducción. Es muy difícil mostrar lo que pasa del cablito, porque para dar una demostración efectiva hay que hacer data transfer, hay que hacer cosas que no es fácil ver en una sala. Entonces pensamos que la manera mejor era comparar el sistema antiguo, sistema corriente, no antiguo, no es nada de roba vieja, roba buena, pero limitado porque tenemos un ancho banda correntemente limitado. En este momento estamos mirando la plataforma del Observatorio Paranal, eso es el Cerro Paranal, se ve en el fondo un telescopio, un colega, Andy Wright, de la persona que nos siguió y nos ayuda en todo el desarrollo técnico de este proyecto. Y bueno, hi Andy, how are there?
Hi Giorgio, good afternoon.
Ahora, es espectacular que nosotros podemos hablar y ver a alguien que está arriba de Paranal. Pero como alguno puede haber notado, la calidad de la imagen, la naturaleza del movimiento, por ejemplo, la mano que se mueve tiene 15 dedos. Eso significa que el sistema no puede transmitir demasiada información porque no tiene suficiente capacidad. Entonces, decidimos de poner EVALSO. EVALSO es un segundo equipo de videoconferencia, por eso se ve en colores un poquito diferente porque son dos cámaras no idénticas. Y en este sistema tenemos mucho más ancho banda, lo que nos permite la fibra. De este lado, en este momento estamos usando 1500 kilobytes. De esta parte, kilobits, disculpe, de esta parte 250. Todavía estamos mucho más abajo de la capacidad del cable por sí, porque ahí estamos hablando de 10.000 de kilobits, pero, de megabits, pero ya vemos diferencia entre las dos imágenes. El movimiento es mucho más fluido porque el sistema puede transmitir mucho más datos al mismo tiempo. Andy, you're great. Now, say something because I want to give a feeling also on the audio.
Yeah, well, as you can see, I'm stood on the platform here with actually UT2 in the background. As you can see, we have wonderful weather here again. So
this is the 365 days per year that there is sun in Paranal, I guess. So the very important point, I don't know what you have noticed, but the audio is very good. And the audio is one of the things that people that know these kind of things will suffer because of a lack of bandwidth. It's typical. If you have a limited bandwidth, the audio is bad. This is your telephone is everything. If you have good bandwidth, the audio is very good because you do not lose information. And therefore, one of the measures of this quality is the dynamics of the movement. Many more data can be transmitted, and the fact that we do not lose packets, we do not lose information. So, thank you, Andy. It was very nice to talk with you.
yeah, you're welcome. Have a good afternoon.
So basically now we can think that it's time to probably to stand to sleep the last thing that I want to show you is a very simple thing, is just the connection with OCA. In the moment on the back we have an image that is the OCA observatory, taken by camera over the fiber. Here we have a very simple camera, so there is no quality, etc. But basically this shows that the functionality, the two things are completed. Now, I think we have a little short pause at the moment, and we resume immediately. Just say where you are, and in a few seconds we will start again. We just want to take the opportunity to show you a little movie that we have prepared in terms of presentation and dissemination of the information. This will be available on the ESO web at this point. And
25 DVDs. Until now, astronomers are observing the sky at Pico's Paranal Observatory in the Chilean Atacama Desert. In the course of the night, the telescope on the mantle will collect around 125 gigabytes of data, enough to fill more than 25 DVDs. Until now, sending this huge amount of data back to ESO headquarters was massive technical challenge, but a new fast link promises to make these difficulties a thing of the past. This is the ESO Path, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the ultimate frontier with our host, Dr. J, aka Dr. Joe.
Hello and welcome to another episode of ESO Path. Today we're going to visit the parallel state of the Chilean Atacama Desert. Here, an international consortium that includes ESO has recently finished installing a new high-speed data cable. This is part of a project to improve the communications link between the Parallel Observatory and ESO headquarters in Germany.
The project is called Enabling Virtual Access to Latin American Southern Observatory, or EVALSO for short. It is part funded by the European Commission's FP7 program. ESO headquarters in Garfing a few weeks before EVALSO's completion. This site is 5 time zones and 11,500 kilometers away from Paranal. The night might be over for the astronomers in Chile, but work is in full swing here, with powerful servers downloading and archiving the new observations from the VLC. Because of limited bandwidth and the micro connection between Paranal and the internet data backbone, it isn't always possible to get observations through straight away. Most of the time, VLC data arrives within a few minutes, but sometimes it takes hours. Delays of this magnitude aren't really a problem, but the operation of the recently commissioned VISTA, the Visible and Infrared Survey Telescope for Astronomy, poses much bigger challenges, as it produces about 4 times as much data as the VLC every night.
In the past, the connection between the observatory and the outside world consisted of a microwave link, which was somewhat limited. Even after an upgrade in the spring, it was only able to transfer data at about the same rate as your broadband internet connection at home. Now remember, this had to serve a whole astronomical facility, with several world-class telescopes, as well as the usual internet and email traffic of the more than 100 staff that worked there. So, this meant that bandwidth had to be rationed. In particular, the data from VISTA could not be sent through this link. Since the data rate from VISTA far exceeded the capability of the microwave link, the observations from this telescope had to be saved on hard disk first, and then physically shipped back to Europe. A simple but somewhat impractical solution for a state-of-the-art observatory.
At the heart of EVALSO is 100 kilometers of newly laid data cable connecting the Chilean city of Antofagasta and 2 observatories, Paranal and Cerro Armazones. Armazones and its nearby peak currently host the observatory of the Ruhr University of Gotland, and if all goes to plan, the European Extremely Large Telescope, EELT, will be built on this mountaintop in the coming decade. In practical use, EVALSO is more than 100 times quicker than the old microwave link, and it can be upgraded to be faster still. With EVALSO, a whole DVD movie can be sent from Paranal to ESO headquarters in a matter of seconds. On the microwave link, that would have taken more than an hour. And this means that EVALSO doesn't just make ESO's work faster and easier, it opens up the possibility of new ways of working for the staff and users of the observatory.
And it all comes down to this. At the core of this cable is a bundle of plastic optical fibers. Now each of these is only about twice as big as human hair, and the whole thing is surrounded by padding and a tough skin. Now digital information is encoded as a series of extremely short flashes of light. The user sends down the fiber and decode it at the other end. It's the same tried and tested technology that underpins international phone and internet connections, and it allows tremendous amounts of data to be transferred very rapidly. So, although it's just an ordinary cable, it has the potential to trigger big changes at Paranal.
EVALSO will mean smoother and quicker operations for the VLC, and a change of pace for the VISTA telescope. Staff in Europe will now be able to work remotely with their colleagues in Chile, without having to make the long journey to Paranal, because video conferencing gamma ray burst, which can only be observed for a few hours. This means that experts far away could be able to participate fully in the action, almost as if they were there. This is crucial since there isn't enough time to travel to the observatory before the gamma ray burst fades away.
For Vista, the changes will be more fundamental. Soon, the data from the telescope will be sent back to Europe immediately for analysis. So instead of a long wait, up to 10 days while the hard disks are shipped to Germany, staff at ESO headquarters will have virtually instant access. With the work completed and the testing over, EVALSO is now coming into service. As a result, this remote mountaintop in Chile doesn't feel quite remote anymore. This is Dr. J, signing off for the ESO call. Join me again next time for another cosmic adventure.
We apologize for the change of program, but the subsecretario de Relaciones Exteriores está llegando, así que fue el señor Palacios, el señor Terenghi están recibiéndolo. Podemos continuar con la presentación del señor Cini, que es el director del instituto. Ah, no, aquí están, disculpen.
Giorgio, it's my turn now. No.
Yes, please, Rob. No. Hold on.
Okay.
Here.
Okay, now it's my turn.
Not yet.
Not yet.
I think we have Jose first. Sorry, Ron. Okay, here we have the honor also the Subsecretary of the Foreign Affairs Ministry, Fernando Schmidt, that show once more the enormous interest that there is in this country for not only astronomy, but science and technology. Ahora vamos a la presentación de José, que es director de la presidenta de la reunión, que va a hablar de por qué vamos están tan contentos de esta actividad.
Muchas gracias. En primer lugar, quiero agradecer la presencia del señor subsecretario, de las embajadas representadas por sus embajadores que nos acompañan, las delegaciones que están presentes, autoridades nacionales, europeas, a la comunidad científica, a los amigas y amigos de esta iniciativa. I was strongly advised to keep my talk within 5 minutes, so that I'll do it in Spanish. Much better to accomplish that challenge. Solo decirles que para Reuna es un hito importante esta actividad. La red universitaria nacional Reuna nace a principios de los 90 con un objeto, una iniciativa con cierto grado de timidez de agrupar universidades y hacer una red académica, y trae Internet a Chile. Primer hito importante de esta iniciativa del Consejo de Rectores de las Universidades Chilenas. Luego de eso, hoy día que hacemos una suma, vemos que está asociada a todas las redes avanzadas, uniendo Latinoamérica, Europa y Asia, Oceanía y Norteamérica. Tiene en su paso, fue el proyecto, diría yo, más exitoso en torno a la transferencia
en el corto plazo al sector productivo con la conectividad y el negocio con Telefónica. Dentro de ese orden de cosas, ¿por qué estamos tan felices? Porque en el ADN de Reuna está el trabajo colaborativo, está el hacer grupos que potencien la investigación, la educación, el generar facilidades para que las comunidades científicas se desarrollen y tengan a su alcance con mejor calidad y a una más alta velocidad toda la información que requieran. Además de estos proyectos, Reuna ha tenido algunas experiencias con ALICE, la Cooperación Latinoamericana de Red Avanzada, la Red Clara, ELA, Proyecto CAWAC. ¿Y qué significa esto para los objetos de esta corporación? Es que además potenciamos nuestros socios. Este proyecto en particular va a dejar un sector de la red en condiciones únicas en Chile hasta la fecha, ¿no? Todo el sector norte, todas las universidades que son miembros de Reuna y las instituciones que también se han asociado a partir de su fundación van a tener un acceso y una velocidad y una calidad de transmisión de información única en Chile. No vamos a tener otra. Reuna ayuda a la comunidad académica a concretar proyectos como estos. Para Chile, además, es muy importante, EVALSO debe representar una iniciativa única en su tipo. Va a permitir conectar, ya muy claramente explicada por quien me antecedió, a nivel nacional, ejecución de iniciativas de este tipo, tanto en lo tecnológico como en lo que significa el trabajo colaborativo, para que despliegue una red de alta velocidad con fines científicos que en Chile va a ser importante para el desarrollo. Quisiera terminar mis palabras invitando a todos los actores que participan y que tienen desconocimiento de lo que Reuna ha sido capaz de hacer, a poner atención en lo que puede ofrecer de aquí a futuro. Esta es una iniciativa de la educación superior chilena y hoy día esta iniciativa, con el único esfuerzo del sistema educativo y con la incorporación de los socios que a partir de la fundación se crearon, la pone a disposición del país y la pone a disposición del desarrollo. Y hoy día celebramos este convenio que está especialmente orientado al desarrollo de la astronomía. Muchas gracias.
Gracias. Now it's time for Rolf, that is in Bochum, to say why he put himself in such an isolated, now well-connected place.
Yes, hello everybody. Let me first, okay, you started it again. Yes, I say a few words how EVALSO will change the work at the observatory and the work at our university. Let me first introduce our university. In the next slide you see the campus of the university. It was founded in 1962. It's a fairly large university. We have 20 faculties, 5,200 employees. We have 33,000 students coming from all over the world, basically. Now I will say a few words to our observatory. This whole project started in 2005, and you see the mountain, how it was 2005, the mountain close to Cerro Amazonas. We first had to build a road, an access road, and to make the top of the mountain some sort of flat. And after this we started the building, and in 2008 there was the official inauguration of the observatory. And here you see the image how the observatory is today. Let me briefly mention the telescopes we have at the observatory. First, we have the, so to speak, unique hexapod telescope, a telescope which is sitting on 6 legs. It has a 1.5 meter active mirror, and at the moment we have a high resolution fiber spectrograph where we can observe the entire optical wavelength range with high resolution. The next telescope is an infrared telescope. It's called IRIS, Infrared Imaging Survey Telescope. It's an 80 centimeter telescope which can be used in robotic mode. That means we can observe star-forming regions which are obscured by dust with this telescope robotically. The next optical telescope is called VISOS 16. VISOS means Variable Young Stellar Object Survey. So with this telescope we also observe star-forming regions in the optical. And it's also a telescope which can be used in robotical mode. Another telescope of this VISOS family are these two small refractors. They work already since several months in robotic mode, and with EVALSO will this work even better. They can produce a very large field of view, and we make every night surveys of the Milky Way to look for changes in star-forming regions. Finally, the last telescope is a telescope from Berlin. It's the Berlin Exoplanet Search Telescope. And this telescope is also operated from Berlin in robotic mode. It looks for extrasolar planets, and it supports the Corot mission, satellite mission, which looks for extrasolar planets. Now, a short word to the energy of the observatory in this remote place. We have installed 100 photovoltaic modules. Each has 130 watts. And in addition to this, we have 2 wind turbines. We will replace these 2 wind turbines by 3 new ones in November, and we are proud to say that this is the first green observatory in the world. Which benefits do we have from EVALSO? I show you a few examples. First, of course, we have real-time access to variable phenomena. You need not to be an astronomer to realize that this object, which is shown here, is variable from night to night. And if we get the data only 5 days or 5 weeks later on hard disk, we cannot react to these changes. But if we get the data via EVALSO the next morning, we can plan our observing for the next night very efficiently. The next application for EVALSO are objects which are not known to be variable, which are discovered by chance, but by our surveys, and I show you here a couple of variable objects. Whenever we see in the morning when we get the data there is a variable object, we can plan our observations for the next night accordingly. It's much better than to wait 5 weeks for a hard disk. So this will make a big change with EVALSO. Another thing, of course, is the remote real-time control of telescopes. Right now I have to send students and scientists over to Serra Amazonas to do the work there. With EVALSO we can operate the telescopes in remote mode, so we sit in Bochum, press the buttons, and the telescope work in Chile. Another even more efficient way to observe is robotic operation. That means here you see the student sitting at the telescope and freezing. With EVALSO they press the button in Germany and go to bed, and in the next morning they will have their data. So that is a very efficient use of the telescope and personal time. To summarize what EVALSO will give us in the future, that is the availability of high bandwidth communication to the observatory infrastructure will allow us to achieve several things. We will reduce travel costs, reduce the time of the people, reduce money and reduce contamination, thanks to remote real-time control of the telescopes and their robotic operation. Another thing is, of course, we will reduce transfer costs by replacing shipping over the hard disks to Germany. We just transfer the data and have them immediately in the morning. And as I have shown you, we can immediately respond to newly discovered variable phenomena, which we discover in the morning. We can plan the observations in the night. And another aspect is, of course, education. The use of remotely controlled telescopes with good links, video and quality will help me during the educational process, teaching and training the students without the need for expensive traveling, shipping students to Chile, and therefore it's more affordable for the students and for our university. Thank you for your attention.
Thank you. I have to replace the Director General that, as I say, has been asked to participate in the other event today. I'd like to tell you why ESO is been so interested in this project. Because we have a tradition to work to try to facilitate the life of astronomers. Here is an article that we published with Gianni Raffi for the first experiment we did in 1984 for remote control of our telescope from La Serena, telescope on La Silla. If you look at the next slide, can you change? Here you see a young Massimo Torenghi. You see the difference? And it was funny because everybody was laughing about us. We started with Gianni Raffi to put two computers next to each other at the telescope with 1 meter cable. And then we explained to the people we do remote control. And the people, haha. So then after this 1 meter, we decided to go to La Serena. And we used a technology available at that time, was a telephone line. We were at La Serena, and there was a big explosion. It was different time. And we lost completely the computer. We had nothing left. But the telephone was still existing. So we were able to download the program, it was on the mountain, to La Serena. And it took us half a night, from 8 o'clock at night until midnight. I think that today, with the EVALSO, a few seconds would be probably sufficient. It's a change. But there was also another change. At that time, the line was one direction. And so it was possible to control or communicate, but it was not possible to do the both things. And so after midnight, the test was so successful, we observed all night long, remotely, until 6:35, when we decided to stop. But we still had somebody at the observatory, a night assistant, to control that everything was okay. And then we called the night assistant on the same line and say, well, listen, could you just close because we are finished? And he said to us, yes, but can I first go to the toilet? The poor guy was waiting for 6 hours, our communication. The problem is change, and I think today we're celebrating a big change. And a few months later of this article, Sky Telescope, in an article about remote control, he quoted me say that we start to remove the astronomer from the telescope, put in the control room. Now we are removed from the mountain. And now we are removed from the continent. This is the new way. We will be able to control everything from everywhere in the world if we will take benefit of this fantastic result that these people have shown. In the middle of nowhere, you can communicate. You can see the flag of 14 years of country in real time. And I think this, of course, with the connection of OCA and the great work, the University del Norte and Bochum, we will facilitate also now the possibility to connect the next big giant telescope that ESO is building. So I think we are all working in the progress. But I'd like to say one thing, that this demonstrated once more, if it's necessary to demonstrate. The astronomy is a very important science that includes a lot of technology. And this technology that we are developing to see the faintest photon, or maybe to transfer a very interesting image immediately from one side to the other side, can be beneficial to the rest of the world. In my opinion here, we cannot just celebrate the success of connecting a telescope with an observatory, or more than one observatory, the possibility to communicate better between different places, including this beautiful country that has a lot of desert, beautiful places in which we operate very important equipment. I hope that soon, we will already discuss this morning with our Japanese colleagues, we will have more connection with other observatories, and this link of change information is going to be the normal thing and not a special. Thank you very much for to all the people that work, and also within community. And I think now, Mario, is your time to, it's a pity that you're not here, because we would like to take you, as we take some of your colleagues this afternoon, to the Paranal Observatory, but we have an open invitation for you. Mario?
Thank you very much. I would be the first to be really willing to be with you today. Not just because I would be closer to where the things are happening today from our collective perspective, but also because this moment is for me the culmination of a long process that in the beginning I think started as a dream and progressively, not without difficulty, have been transformed into some kind of reality. And the predecessors, the one that spoke before me, just highlighted some of the important aspects that we are celebrating today. Yes, it is important that all the astronomers get the best access possible to such an important investment that the European Southern Observatory has made in Chile. Yes, this was, say, the reason why the supported by the European Commission. It's also true that doing so, we also gave the opportunity to experts in Chile and in the ESO premises down in the South American side, get quick access to other resources that could be of importance in Europe. It is also very interesting to see the side effects of this project, because in fact having this high capacity in terms of communication bandwidth, having this will reinforce not only the aspects of the connectivity to the Paranal centers of excellence on radio astronomy, the astronomy in general, but also helping the Chilean Research and Education Network to reinforce the links in national terms, and last but not least, contributing to ensure that Red Clara has as large footprint with high capacity as possible. And so that's very important, these synergies between those different endeavors. And it is also very interesting to look into the aspects of the influence in the market, because obviously procuring this sort of bandwidth in Chile and in Latin America sets a precedent that could be important for the citizens in general, certainly a precedent that can be very important for the scientific community in Latin America. In fact, I think that in this respect, EVALSO pioneered to a very large extent the telecom market in Chile for access to dark fiber and to ensure that this could be a path stimulating competition in the rest of the sectors. But as some of the colleagues that spoke before me highlighted, I do believe that the major importance of what we are celebrating today is not in any of those aspects that by themselves are extremely important. The real breakthrough is the opportunities that those infrastructures open to do science in a different way. It's very important to understand that those investments are triggered by new ways of doing science, and themselves they will ensure that science in the future will be done in ways that we hardly can conceive today. With these links, we have seen already some of the things that can be done. The real-time aspects have been highlighted. I would like also to emphasize the huge amount of data that has been collected, and therefore the emergence of simulation and data, scientific data, as a real infrastructure for the scientists in a lot of domains, but in particular in astronomy. And so what we are witnessing is that we are putting here and there some elements of infrastructure, be it a high-speed connection, be it a more efficient way of computing some of our algorithms, be it a synergy between remote and distributed resources of different kinds, computing, supercomputing through grids, involving specific equipment with sensors, with actuators, being able to monitor and also influence on a real-time basis the type of observations that we are doing. And all those little elements that are being put in place will contribute, all of them, to make the scientific process more efficient, to make us to get more out of the budget that we invest, and to ensure that the scientific process leads to breakthroughs that could not be managed before. And this is really what we are all contributing to. You, in some sense, with your ideas, with your vision, being the actors that will put in place new concepts and explore the infrastructure that are there. We, as a funding authority, also trying to capture your vision, to try to incorporate this vision into what we call e-science or digital science, trying to make our funding mechanisms adequate to make sure that science is done in a different way in the future as compared to today. So I'm very proud to be here today. I think that we in the Commission are all very proud. Jean-Luc in Brussels, that has been following with a lot of attention and care and commitment this project. All my colleagues that prior to me and that after me has been looking into those aspects of ICT-based infrastructures. Throughout this process has demonstrated the stamina, the rigor, the commitment, the knowledge to maintain those ideas alive. And we are just here today, in this moment, inaugurating something that to a certain extent is the complement of so many other activities that take place in Europe, in the United States, in other parts of the world, all of them contributing to making sure that astronomers have their life made more easy, that they can do the type of research that they ambition to do, and that they can give to the society the benefits that we expect from the investments done in research. Personally, I'm very grateful to a number of you in Latin America and a number of you in Europe that have committed so much time, so much resources, so much knowledge, so much of your care and passion to make this EVALSO project a reality. to make projects like Red Clara and others that are so important in this context also a reality. We are very thankful to all your work, and we just share the moment. We smile because we see that we come to a moment where our efforts bring fruits, and be with us. All of us in Europe are very, very happy that you colleagues over there have reached such a tremendous success with this initiative, and we wish you all the best, expecting to see the results of those investments in the future discoveries that I'm sure you will be pioneering in the future. Thank you very, very much. Thanks for inviting me to share this moment with you.
Thank you very much for this nice word from Europe. Now we'd like to have some more from Chile, because this we are celebrating the connection once more between Chile and Europe, between science, technology, astronomy, and activity, human activity. Fernando.
Okay.
You have it?
I have this one. I'm not very much used to this. Huh? Well, Mr. Massimo Zarengi, representative of ESO here in our country, Mr. Fernando Liello, director of the project EVALSO at the University of Trieste, Mr. Giorgio Filippi, project manager for the EVALSO infrastructure, señora Sandra Jaque, gerente de tecnología y operaciones de REUNA, señor José Palacios, presidente del directorio de REUNA, and Professor Dr. Rolf Chini from the Universität Bochum, señor Mario Campolargo, Director for Emerging Technologies and Infrastructures, and currently at the University of Aveiro. Ladies and gentlemen, talking about astronomy for a lay like me, it is not easy. I prefer to read, and to read it in Spanish. Otherwise, I could make a lot of mistakes. But I want to start by something very simple. I'm very proud for the achievements of ESO here in our country, and for the policy of constant support that different governments of Chile have been given to the European Southern Observatory, for the incremental number of research that ESO and other institutions have been accomplishing in this country for mankind. Hoy por hoy, Chile, gracias a las excelentes condiciones que ofrecemos para el desarrollo de la astronomía, se encuentra en una posición donde se están presentando magníficas oportunidades para el desarrollo científico, para la innovación tecnológica, para el desarrollo digital, para los negocios tecnológicos, el emprendimiento. El impacto provocado por una buena performance de nuestro país traerá consigo el desarrollo económico y, por cierto, el liderazgo de Chile a nivel regional en dichas materias. Hoy día hay dos impactantes noticias que tienen de alguna manera que ver con lo que acabo de expresar. El World Economic Forum ha colocado a Chile en el 30º lugar dentro de todas las economías analizadas del mundo, como uno de los países, por lo tanto, más atractivos desde el punto de vista financiero, desde el punto de vista de la estabilidad, desde el punto de vista de sus condiciones económicas, para poder desarrollar mayores actividades, mayores inversiones. Hoy, antes del mediodía, las noticias que acabo de revisar. El auspicioso crecimiento económico se anuncia para este año en aproximadamente un 7%. Por lo tanto, agradecemos en primer lugar esa tremenda confianza que eso ha contribuido a acrecentar. En el ámbito científico, nuestro país ha recibido y seguirá recibiendo el grueso de esa inversión astronómica mundial. En unos años más, Chile va a concentrar más del 70% del área de los espejos de los telescopios más grandes del mundo. Si bien estamos conscientes de las grandes oportunidades que esto significa, tenemos muy presente también los grandes desafíos que conlleva, como por ejemplo, el desafío que se presentará en el ámbito digital, donde se deberá procesar y almacenar trillones de datos digitalizados que en un futuro cercano se convertirán en grandes descubrimientos para toda la humanidad que tendrán su origen en nuestro país. Por todo lo anterior, la iniciativa EVALSO representa las acciones que el gobierno está buscando tanto a nivel tecnológico como de cooperación. Gracias a la asociación entre 9 miembros, entre ellos la European Southern Observatory, el Observatorio Cerro Amazones y Reuna, también la Universidad de Trieste, y con el apoyo financiero de la Comisión Europea dentro del 7º programa marco, que fue suscrito en enero del año 2008, hoy nos encontramos aquí para el lanzamiento de una iniciativa única en su tipo. Aun cuando existe también en Brasil algo similar, pero es una iniciativa única en distintas esferas, porque permitirá conectar, y como lo hemos visto recién por estas videoconferencias, por la brillante exposición del profesor de Bochum, conectar a los observatorios astronómicos de Paranal y Armazones en tiempo real con Europa, con la comunidad académica nacional, mediante una red física de alta velocidad. La instalación de esta red no solo se traduce en un beneficio para la astronomía, sino que tiene un gran impacto en el mundo académico y docente, ya que propicia la colaboración en diversas áreas del quehacer científico, tanto nacional como extranjero. Gracias a la infraestructura desplegada a través de EVALSO, Chile se sitúa a la par de los países desarrollados en materia de generación de plataformas tecnológicas que interconectan a las instituciones de I+D y contribuyen de esta manera a su crecimiento. Este proyecto es un paso importante, muy importante diría. Es el comienzo de una gran tarea para que el país posea infraestructuras de base para el desarrollo de la ciencia y la tecnología. Cabe agregar que sin lugar a dudas EVALSO pone a Chile en una mejor condición tecnológica para enfrentar el desafío de la instalación de los grandes observatorios astronómicos en nuestro país. Gracias a esta red de alta velocidad, Chile adquiere una mejor posición para atraer nuevas inversiones en el ámbito de la astronomía. A partir de esta infraestructura, nuestro país no solo ofrece las mejores condiciones atmosféricas, como lo demuestran las fotografías de la entrada, son muy impactantes, estabilidad política, como lo demuestra ese importante crecimiento de la inversión, crecimiento económico y posicionamiento, a su vez, como uno de los países más atractivos. Las mejores condiciones de seguridad, sino que también cuenta con una infraestructura de base que va a servir como soporte para el funcionamiento de cualquier proyecto en esta línea. Esperamos como resultado de esto aumentar esa conciencia crítica en la comunidad científica, un mayor volumen de indagadores, de personas que quieran buscar nuevas respuestas a través de esta ciencia fascinante a los problemas del mundo actual. Queremos también, y por supuesto, establecer la mayor conectividad global. Aquí hay científicos reunidos principalmente de la Unión Europea, pero esta red de observatorios es una red que va también en direcciones muy diversas y va instalando a Chile dentro de una plataforma de privilegio en la comunidad científica mundial. Lo felicito por esta red, por esta inauguración, por este proyecto. Y deseo el mejor y más auspicioso de los futuros. Muchas gracias.
Gracias al secretario. Ahora tenemos un pequeño cóctel que va presente acá. No tenemos, Reina no tiene posibilidad de pasar cóctel también de forma remota.
De forma remota no, eso no.
Vamos, Mario, la próxima vez vamos acá un buen trago. Gracias a todos y gracias en particular a Chile, que es tan fuerte. Es un apoyo de la astronomía, es la capital de la astronomía mundial. Gracias.